right, we are continuing on with a little bit more of notes, and then we'll look at some examples for these geometry problems that we're looking at. So I did show you a triangular prism a little bit ago, and I can go into this later if anybody is interested. It's really not going to actually be covered in ALEKS either. It's just that idea that if you know the base, the area of the base, then if you multiply by the height, you can figure out how much space something is taking up. There are some specific formulas for the volume of a cube, right? Again, this is the specialized version of a rectangular prism. So every edge is S. So this is S, and this is S, and this is S. So if we want the volume, then I would just cube that. Length times width times height, just like for the rectangular prism, but they're all the same, so S cubed. And then the surface area is a little bit different. So if you think about, and actually here, let me just, this isn't a cube, but just like look at this little box that I have here. So it has the top and the bottom, has a left and a right, and it has a front and back. And when we figure out the area for all of those and add them together, that's going to be our surface area. So for a cube, then each of these faces is going to have the same area. And since that's the case, we can just say, all right, well, there's 6 of them. So I can just multiply the area of this, which is S times S, by 6. And, when you're thinking of cubes, dice are the exactly what we're looking at. Okay, so here's some teeny tiny dice that you can look at, and you can see, you've got 1, and then if you look at the opposites, right, 3 and 4 are opposite sides, 1 and 6 are opposite sides, 5 and 2 are opposite sides. So you get 6 faces on here. And if we find the area of one of them and multiply by 6, then we get what we would have to completely cover that cube. And let's see, one last thing that we're going to look at is the volume of a cone. With the cone, it's similar to a cylinder. So I did find my cylinder example here. So we've got a circle base, top and bottom, and then it's straight sides all around there. Looks like a tiny can, like a soup can. With a cylinder versus a cone, obviously the cone is coming to a point, and the cylinder is straight up and down. Like I said before, you could think about it as a stack of coins. Like if you're rolling coins to take into the bank, then that is another way to think about it, a cylinder. So with a cone, we're not keeping each of those layers the same size. So we are continually reducing them until we get down to the point. And what happens is that we end up with 1/3 the volume of that cylinder. So the formula for the volume of a cone is going to look really familiar because this part of it here is the volume of a cylinder, and then we multiply it by 1/3 or divide it by 3, same thing, and that will give us the volume of the cone. So this is known as the height here, and I was using yellow for height before. And then we need to know the radius, that halfway across radius value. And if I have those two pieces, I can find the volume of any cone with that height and that radius. And again, we can just, do 1 divided by 3 times 3.14 times whatever that radius is squared times h, and then hit equals in our calculator, and that will give us that value. If you're having any issues, how do I get things in the calculator so that I get rounding to the same place as ALEKS, then let me know, because I can run through that with you a little bit more specifically. All right, so those are the different shapes, and like I said, we're not really going to be looking at anything on these on the test or the exam, but I'm just going to run through a couple, kind of give you a little reminder. If you had 38, then you did a little bit with these last semester. for before now, but may not have seen these for a little bit. All right, so these examples, which are on page 4, are looking at area and perimeter or circumference, depending on what the figure is, and finding those and using 3.14 for pi. And pretty much everything you do in ALEX will be using 3.14 for pi so that we all round to exactly the same place so we can get a consistent answer. All right, area is often easier. So if I do length times width, so area is 25 centimeters times 15 centimeters. And then after I multiply those together, you always want to make sure to label these things. And that is going to be 375. And then because we are figuring out how many little squares does it take to cover this figure, it is centimeters squared. It's a two-dimensional figure, so it has to have the squared for the exponent there for area. So area squared units. Circumference or perimeter for this figure, so it's a rectangle, so right, so perimeter is 2 length plus 2 width, and that's going to be 2 times 25 centimeters plus 2 times 15 centimeters, so 50 centimeters plus 30 centimeters, and we add those together and we get 80 centimeters. And that's just going to be centimeters with a 1 as that exponent there, because we're just figuring out how far around is it. We're walking around. When you're measuring distances, we are looking at just plain old units, so centimeters in this case. All right. This next one, if it looks like a square, pretty much you can assume that it is, especially if they only give you one dimension. That means that this one would also have to be 32 inches. And then we can use these same formulas. You can use the square formulas, whichever you prefer. So let's see here. Area is length times width. They just happen to be the same here. So 32 times 32. And that is 1,024. And then because it's inches and it's area, it's going to be inches squared. Perimeter. All right, so there's 4 sides for a square that are all the same. So 4 times 32, and that is going to be what? 128 centimeters for perimeter. Okay, the circle here. First thing you need to do with circle problems is decide if you have been given the radius or the diameter. And this one does go all the way across. So that is a diameter. So that means diameter is 12 yards. And I recommend immediately finding what the radius is also, right? You just cut it in half. So 6 yards. Because the diameter is all the way across, radius is halfway across. There's your R. And you've got both pieces now, so area is pi r squared for a circle. And we're going to use 3.14 for pi. And the radius was 6, so 6 squared. 3.14 times 36 is going to be 113.04. Typically, they're going to have you round to the nearest tenth, but just follow the directions carefully. And if it's on a quiz, then you've got some wiggle room with me, especially if the directions don't specify. And don't forget, though, that this is yards squared. Make sure that you're labeling these things. Circumference, then, you can use either formula. So you can either is pi d or circumference is 2 pi r. I had the diameter already, so I'll just throw it into that one. Really doesn't make a difference, right? Exactly the same idea. So 3.14 for pi, and then 12 yards for the diameter. And that's going to give us 37.68 yards. And not squared, right? We're just figuring out how far to walk around the circular path. And we figured distances that we walk in yards or feet or centimeters or inches or whichever of those. Okay, we're going to flip over and look at, I'm actually going to skip a page here because we don't need to worry about the piecemeal area ones. Let us go over here to the surface area ones. So surface area of a box using 3.14 for pi as necessary. So for the surface area of a box, so we have 2 length times width plus 2 width times height plus 2 height times length. So basically each of these faces we need to figure out, and that there's 2 of them. So if I look back at my little box here, so right, there's a top and a bottom, there is a left and a right, and then there's a front and a back. So if I figure out half of these sides, I just double them, and that gives me the rest of it. All right, so I will identify this as the length, this as the width, and then this one as the height. It really doesn't make a difference as long as you are consistent throughout your formula, because of the way that we find the surface area for the rectangular prism / box. All right, so 4.5 times 1.75, 2 of those. And then 2 with width and height, so I'll take the 1.75 and the 7. And then 2 with the height, 7, and the length of 4.5. And at that point, it's a matter of plugging it appropriately into my calculator and then putting on the correct units for labeling. Let's see here. I am just going to do the intermediate step here. And see what you get for these. Okay, this is 24.5 and then the surface area is going to be when I add those up. All right, so all together I have 103.25, and then remember it's inches, and it is an area because we're covering things, so it is squared. Squared units on that surface area problem. All right, I'm going to skip the cube. Let's look at the cylinder here. So again, this is like my little Farkle canister here. So we get a value, which happens to be the radius here because we're halfway across, and then the height is going to be the other value that we have given to us, and that is sufficient to find the volume of the cylinder. So the volume is pi r squared, so the area of that circular base, times the height. To tell us how many of slices of this base are we going to have. So that's H, and this is R. And let's see here. Reminder, there's R. And H is going to be this perpendicular distance between the 2 bases, right? So this is the height because it is perpendicular between the 2 circular bases we have. And then we can go into plugging those values in. We have R, we weren't given the diameter, so we can just plug it right in. Oh heck, I was supposed to be doing surface area here. Darn it. Okay, just a moment there. So surface area is 2 circular bases, right? One on top, one on the bottom. So 2 times pi r squared plus this rectangular outside. So think about the label that's on this one, or the label that's on a can of soup. And that is going to be 2 pi r, the circumference, times the height. And that's a squared there. All right, so then we plug those values in, and my video is about to run out, so we will continue this on the next one.